Now, the reactions I gave you, if you're familiar with chemistry, you may have noticed that they weren't balanced. So we're going to discuss the general technique of balancing reactions and what does it mean to balance a reaction. If we're going to use a written chemical reaction to calculate amounts, say of products or amounts of reactants that are used, we have to start with a reaction that's said to be balanced. So besides writing the formulas of the reactants and products, we write how many are involved. So for example, when I write H2O in a reaction, it means one molecule of H2O. If I write 2H2O, it means two molecules of water. That's four hydrogens. In terms of atoms, that's four hydrogen atoms and two oxygen atoms in all. And then for ionic compounds don't generally come in units of don't come in packages of molecules. But when I write say magnesium chloride, MgCl2, that means one so-called formula unit of magnesium chloride, which consists of one magnesium atom and two chloride. A balanced equation must show the same number of atoms on each side. So here would be an example. Maybe I would write O2 plus 2H2, means two hydrogen molecules goes to 2H2O. And what this means, here's a picture of what this would mean. There's an oxygen molecule consisting of two oxygen atoms bound together. Then this side of the equation shows two hydrogen molecules, which is four hydrogens in all. This side of the equation shows two water molecules. And notice that when I go from over here, from the left side to the right side, I have the same number of hydrogens, four hydrogens on this side, and I have four hydrogens on this side. And similarly, oxygens, I have two oxygen atoms on this side and two oxygen atoms on this side. And in a balanced chemical reaction, I see the number and kind of atoms does not change. So I'll go through some of the examples. The other examples I showed. This particular equation shows the baking soda in acid, and I look at this and I see that's balanced as it is. We'll look at the sodium atoms. There's one sodium atom on this side and one sodium atom on this side. And hydrogens. There's a hydrogen here in this formula unit and a hydrogen here, and there's two in this water molecule. So two hydrogens here, two hydrogens here. Oxygens, I see this formula, or carbons. I see there's one carbon on each side. The sodium bicarbonate has one carbon, and over here there's one carbon in the CO2. And then finally, I see three oxygen atoms on this side, three oxygen atoms, And then I have the water molecule has 1, the CO2 molecule has 2, so there's 3 oxygen atoms on this side. And so this is balanced as it's written. If I don't write coefficients in front of a formula, 1 is implied. Let's look at the next one. Calcium chloride, sodium hydroxide goes to calcium hydroxide and sodium chloride. When I see ions appear, like hydroxide here, I can often, it's convenient if I just think of that as one unit, which ordinarily in chemical reactions remains unchanged. So the hydroxide is almost like a separate atom, and I don't have to count oxygens and hydrogens separately. So I see that there's calcium is balanced. There's 1 calcium on this side, 1 calcium on this side. Chlorine is not balanced. There's 2 chlorines here and only 1 chlorine here. Well, I can try to fix that by putting a 2 in front of the sodium chloride. Having done that, I see that there's 2 sodium atoms on this side, only 1 on this side. So I'll put a 2 there. And then I see at this point, at this point it's balanced. That automatically balanced the hydroxides. The HCl and NH3, I think it should be pretty obvious that those are balanced, as it is. Let's balance this next one, and this will be an example of balancing a so-called combustion reaction. Well, the first thing I see is 2 carbons on this side here, only 1 carbon here. So I'll start out by putting a 2 there. In a combustion reaction, the next thing the next most convenient thing to do is balance the hydrogens. I see 2 hydrogens here, and there are 2 here, so the hydrogens are balanced as it is. Now, how about the oxygens? I see an oxygen there and 2 there. There's 3 oxygens on this side, but the only thing I have to work with are O2 molecules here, and it's problematic that I have an odd number of oxygens on the right-hand side. So what I'm going to do is I'm going to basically start over, get rid of these things, and start with two of those acetylene molecules. Now, so I'm going to balance everything with double the coefficients I had before. Now I see I want 4 CO2, because now there's 4 carbons on this side. I see that there are 4 hydrogens, so I need 2 water molecules. And now on this side, I see this adds up to 2 oxygens from these water molecules, 8 from the CO2s. 8 plus 2 is 10. 10 oxygen atoms, which I can make up by 5 oxygen molecules. And that equation is now balanced. It's common to indicate the states of the reactants or products in a reaction. So for instance, solids are indicated by S, liquids by L, gases by G. And then another special symbol in parentheses, AQ, stands for aqueous, and that's when a substance is dissolved in water. As an example, let me write the baking soda. Let's say I start with solid baking soda, and I put the S in parentheses like that. I add to that hydrochloric acid in an aqueous solution, and so I write AQ. And for my products, I make carbon dioxide gas, and I produce water. Water is a liquid. So this is illustrating all of these. And then finally, the other product I make is sodium chloride, and that's an aqueous solution. So that illustrates using that particular notation.